Welcome to Homework Lib.
Part A of the problem, we need to calculate the magnetic field at the location of the coil for t is equal to 2 seconds. The EMF induced in the coil is given by E is equal to number of turns, rate of change of magnetic flux, d phi b divided by dt, magnitude, where the phi b, the flux, is equal to area times magnetic field. Then substituting a B, we can write EMF to be A times N dB divided by dt. From here, then dB divided by dt, rate of change of magnetic field, is equal to EMF divided by A times N. The induced EMF can be written as in terms of induced current and the resistance. And we can write dB will be divided by dt is equal to Ri divided by An. Then dB will be equal to so dB is equal to Ri divided by A times N dt. Integrating B will be equal to integral of dB. That is integrating from 0 to 2 seconds Ri An dt. So integrating with respect to I, we get so this will be R divided by An, integrating 0 to 2 seconds I dt. From the given graph, we can find the value of the integration by calculating the area under the curve from t is equal to 0 to t is equal to 2 seconds. This will be I integral of 0 to 2 I dt is equal to the area. That is equal to 1 over 2 times 3 milliampere. This gives us 0.00300 ampere seconds. Then we substitute this value in the equation that we wrote before and find dB from 0 to 2 will be 0.00300 times R divided by An. So substituting values for Rn, which is 0.250 ohms times 0.00300 divided by pi r square is the area, which is R is 0.00800 square times 4. This gives us dB from 0 to 2 to be 0.9325 Tesla from 0 to 2 seconds. Part B of the problem. Now we calculate the magnetic field at the location of the coil for t is equal to 5 seconds. This will be equal to so dB magnetic field from 0 to 5 will be equal to magnetic field from 0 to 2 plus magnetic field from 2 to 5. So we'll calculate 2 to 5 dB. That is 2 to 5 will be equal to R times, using the formula that we wrote previously, is the area under the curve. So area under the curve divided by A times N. So we substitute the value 0.250 ohms is the resistance, times the area under the curve for 2 to 5 will be 3 times 10 to the power minus 3 A times 3 seconds divided by pi times R 0.00800 square meters times 4. This gives us dB 2 to 5 is 2.798 Tesla. Then dB from 0 to 5 will be then 0.9325 Tesla plus 2.798 Tesla. This will give us 3.73 Tesla. Part C of the problem, from 0 to 6 seconds, the magnetic field at the location of the coil, part C, will be equal to dB 0 to 6 will be equal to dB 0 to 5 plus dB from 5 to 6. So We already know from 0 to 5, which we calculated above, which is 3.73. So we'll calculate now from 0 to 2, 0, 5 to 6, sorry. We see that from the graph that the area under the curve from t is equal to 0 to t is equal to 2 seconds is twice the area under the curve from t is equal to 5 to t is equal to 6 seconds. So dB 5 to 6 is equal to 1 over half dB from 0 to 2. Then dB 0 to 6 will be equal to dB 0 to 5 plus half of the dB from 0 to 2. Then using the information from above, we can write 3.73 plus 1 over 2 of 0.9325 Tesla. This will give us 4.20 Tesla. This is our field from dB from 0 to 6, that is 4.20 Tesla.